Hello everyone, welcome back to my YouTube channel. I hope you are doing well and your preparation for exam is also going well. So here I am with our science chapter, one of the important chapter from science. Okay, you may expect around 6 to 7 marks. Okay, from this chapter, and the name is electricity. Okay, and in this particular video I will be mainly solving the numerical problems. Okay, numerical problems which can be asked. Okay, they are mainly asked for 3, sometime for 2, and can also be asked for 4 marks. Okay, so try to learn them well. Okay, and I'll be explaining with basics first. Okay, basics means first I will explain the formulae which you have to behead properly. Okay, and I will also give some tricks how you can remember those formulae. Then we'll solve the problems which has been asked in the exams, and that is previous exam, and then we'll solve the question, some of the important questions from textbooks also. Okay, so stay tuned till last of this video, and if you find this useful, do press the like button, share it with your friends, and also you can give your point of view in the comment section. Okay, and at last don't forget to subscribe the channel. Okay, so with that, let me start it. So some of the important formula which you have to remember, first is current. I represents current is equal to charge per time. Okay, per unit time. Okay, and you should also know the unit. So current unit is ampere. Small a, it starts with small a and it is notated by a. Okay, q is coulomb. Okay, unit is coulomb and it is represented as capital C. Okay, this is O. Next T is time, and time is always represented in seconds. Okay, small s. Okay, this is charge, current, charge, time. Second we have V means voltage. It is also called as potential difference, and V is equal to work done to transfer charges. Okay, so here V is voltage, its unit is capital V volt, and W is work done. Okay, and its unit is joule. You have to remember these SI units also. Okay, then we have Ohm's law. V is equal to IR. Okay, so just remember Veer. Okay, there is a movie in Kannada also, you can remember this Veer, or in Hindi Veer. Okay, okay, V is equal to IR. Just remember, V is voltage or potential difference, I is current, R is resistance, and unit of resistance is ohm. So this is most important formula which we are going to use many times. You will come to know while solving the problems. Next we have one more important formula which is called as rho. Okay, and it is read as rho, rho, but its name is electrical resistivity. Okay, remember this, electrical resistivity means resistance per unit meter. Therefore its unit is SI unit is rho meter. Okay, remember that also, and it is RA by L. Okay, example, there is a wire like this, circular wire. Okay, current will charges will flow in this, right? So R is the resistance offered by this conductor or wire. A is the area of cross section, so it is always A. It is if you look from this side, if you cut it and look from this side, this looks circular, right? So therefore its area is pi r square, or if diameter is given, it is also written as pi d square by 4. So remember this, and L is length of the conductor. Okay, next we have number 5th is this power formula. Okay, electrical power is equal to, we have many formula but this one is very important, VI. So this you can remember with a trick, VIP. Okay, So Vi is equal to P. Very important person, you know that, VIP, or very important point. Remember this. So P is equal to Vi, you can remember. This is the other most important formula. Okay, then we have one more formula related to power. Okay, it is also, it can be written as work done by time. Okay, or work done is also, here we can take it as electrical energy per time. Both of them are correct. Okay, this is also one of the important one. Next we have a formula, and that is heat energy, which is equal to I square R T, and its unit is again Joule, and work done energy unit again Joule. Both of them are same. Okay, Joule. Okay, so T is time, R is resistance, H is heat energy again in Joule. And then we have resistors in series. When two resistors are in series, then total resistance in series is equal to sum of the individual one, R1 plus R2. Then we have resistance in parallel. If there are two resistors connected in parallel connections, then it is 1 Rp is equal to 1 by R1 plus 1 by R2. So these many formula you have to remember. Okay, and remember, when resistors are in series, okay, series, and when they are in parallel, okay, in parallel voltage remains the same, means V over here is equal to V over here. Okay, current is different, remember this. And in series it is reverse. In series I remains same, current is same, and voltage is different. Okay, so you can just remember like this: SI, series, current is same, and then PV, you know PV Sindhu, so you can remember with her name. She's an athlete, Indian athlete, PV Sindhu. PV is in parallel series, voltage is same. In series connection, what is same? In parallel connection, voltage is same, and in series connection, current is same. You can remember like that. Okay. So I hope you have understood all these basics formulae which are required to solve the problems on electricity. Okay. So let us start now. These are the important 1 mark questions I thought of showing it here. You can just answer it by yourself, try to answer them. Okay, you can take a screenshot and let me zoom it. Yeah, so try to answer them all. I have also sent the PDF of this in my WhatsApp as well as the Telegram group. Okay, link is provided in the description box. Here 1 mark questions, you can take the screenshot, and this one is 2 marks questions. Okay, next again we have 3 mark questions. Okay, theory questions mainly I have prepared. Here we have a numerical question which I'm going to solve it soon, the type which could be asked, and the last 4 to 5 mark questions, sometimes they ask like this. Okay, here the meaning they will ask. In science we don't have any longer question answers. They will just ask for 2 marks plus 2 marks plus 1, that will become 5, or 1 plus 1 plus 1 plus 1 plus 1, that becomes 5. Okay, so science is very easy if you have read it properly. Okay, but most of the students get headache from science because they have not understood the concept, they have not understand the concept. Okay, so we'll solve the problems now. I hope you are ready with your book, notebook and pen. Try to solve it by yourself first, then you can compare it. Okay, here is the first question. There's a unit of electrical charge, it is Coulomb. Okay, this is for potential difference or voltage, this is for current, this is for energy, electrical energy or work done. Okay, so here the answer is C, Coulomb. Next is, and if you have seen, all of these names are in small letters, so you should always write them in small letters only. It is a international rule that we have to write. If the name, the unit is in the name of any scientist, we write that in the small letter form. Okay, So I hope you were not aware of that. Now you know that. So thank me in comment section for that. Next, you can check it for any unit. If they are writing the full name, first letter will be small always. Okay. Next question. A piece of metallic wire of resistance R is cut into three equal parts. These parts are then connected in parallel. Okay. If the total resistance of this combination is R dash, then the value of R is to R dash is question mark. Okay. So if I have a resistance of 30, and if I tell you I will divide into three equal parts, what will you tell? You will tell 10 plus 10 plus 10, correct? How you got that? We have to just divide it by 3, correct? We'll get one individual part, isn't it? So that's what we are going to do. We will divide this R into three equal parts. What will be that? R by 3, R by 3, R by 3. So these are the three equal parts, right? Now they have given these parts are then connected in parallel, means these three, okay, R by 3, R by 3 and R by 3, they are connected in parallel. If the total resistance of these combination, now when they are connected in parallel, the total resistance is R dash, okay, then the value of R is to R dash is what? So write the formula. Resistance in parallel Rp is equal to 1 by R1, 1 by R2 and 1 by R3. Now here Rp, resistance in parallel, is R dash. And what about R1, R2, R3? All of them are same, R by 3, correct? So I can write here R by 3, again R by 3, again R by 3. Now 3 will goes to numerator, this becomes 3 by R, again this is 3 by R, and again this is 3 by R. So if you take R common, you will get 3 plus 3 plus 3, that is 9. And what is this? This is 1 by R dash. Now do the cross multiplication. Okay, you can just bring this R here and you can keep R dash as it is. Here 9 and 1 will come to this place, it's become 1. So R by R dash, or R is to R dash, is equal to what? 9 is to 1. So option number B. Most of you might write 3 is to 1, but that is not the right choice, correct? This is how you have to do them. Okay, I hope it's clear. Moving to the next question. Okay, so these are the types of question you can expect in 1 mark section, sometimes for 2 or 3 also. Observe the following table, complete the table using Ohm's law. So what is Ohm's law? Always remember, V is equal to IR is Ohm's law. Okay, Mr. Ohm was a very big veer. Okay, he was Hindi wala veer. So remember this trick. So what they have given in first column, series, in this if you see current is given, potential difference R is unknown. So use this formula. What will be R? If I use this, R will be V by I, correct? V is 120 by I is how much? 2. So this is 60, resistance is in ohm. So answer is 60 ohm. Second, they have given I, R, not V. So use this formula. V is equal to IR. I is this 1.5 into 60. So what is 1.5 into 60? It is 6, 15, 6 and 90. So 9 ohm. This is voltage. So it should be volt, 9 volt. Now in third case they have given V, they have given R. We need to find I. I will be what? V by R, correct? So V is 60 by 60, which is equal to 1, and this is current, so it should be in ampere. So 1 ampere. Okay, so this is how you have to solve them. Next question is the electrical, okay, the resistivity of two conductors A, B are 1.62 into 10 power minus 8. Okay, so this question says the resistivity of two conductors A and B are 1.62 into 10 power 8 minus 8 ohm meter and 5.20 into 10 power 8 ohm meter. Okay, so if you look at these uh, power, both of them have same, so you can just ignore it. Okay, it means they are very smaller values, but you can just look at these two. For A it is 1.62. Since this power remains same, we will not consider that. And for B 5.2, okay, ohm meter. which of them is used in transportation of electricity? So for transportation of electricity, the wire should be good conductor of electricity, right? It should be a good conductor, and good conductor means the resistance should be less, correct? And resistance is less where resistivity is low. Okay, so A has less resistance, therefore its resistivity is less, and therefore it can be used for transportation of electricity. Okay, so A wire is used, conductor A is used. Now the making of heating coils. Uh, Making of heating coils, the heating coil should be such that uh, heating will occur when the resistance is high, and when the resistance is high, it means what? Its resistivity is also high. Therefore option number B, sorry, here it is B, the conductor B should be used because it offers more resistance compared to A. Got it? So this is how you have to answer. I hope it's clear. Moving to the next question now. Here they have given an electric lamp, you can see it here, whose resistance is 20 ohm and a conductor of 4 ohm. They are connected to a 6-volt battery. Okay, you can refer this figure. Calculate A, the total resistance of the circuit. Okay, B, current through the circuit. Okay, and C is potential difference across the electric lamp differently and conductor separately. Okay, so total resistance, they are in series, so just add them. 4 plus 20, it will be 24 ohm, right? Next question is current. So current is unknown, so use Ohm's law. V is equal to IR. I is unknown, so it will be V by R. Voltage given is 6. So 6 divided by resistance, total resistance you have to take 24, which is equal to 1 by 4. You can just write ampere, or else you can also write 0.25 ampere. Both of them are okay, but try to keep it in fraction form. I will tell you why. Next they have asked potential difference across electric lamp. So electric lamp potential, again use V by I R. Now I had said that, remember PV Sindhu? Yes, I had said in parallel voltage is same and in series current is same, but voltage is different. Therefore we need to find voltage separately because they are in series. Got it? So voltage is I. Here I is how much? I is same, correct? In series I is same. I just now you got 1 by 4. See, into resistance is how much? 20. That's why I told you to keep it in fraction form. If you take decimal, multiplication becomes difficult. 4 5s. So answer is 5 volt. And in this lamp, sorry, this conductor, V is again IR. Therefore V will be what is this? I. This is not V. Yeah, V. Okay. V only 1 by 4 into R. R is 4. So this is 1 volt. That's all. Understood? It's very simple. You can easily solve them if you understand the concept. Next is one of the most important question. It has been asked several times. Okay, it's very easy. You just have to remember. Okay, most of you may get confused. We don't have any formula like this, but just see. I will solve this in easiest possible way. Okay, see, they have given an electric refrigerator rated 400 watt is used for 8 hours a day. Okay, an electric iron box rated 750 watt is used for 2 hours a day. Calculate the cost of using these appliances for 30 days if the cost of 1 kilowatt hour is 3 rupees. Okay, so it's very simple. I'll show you. Here you take electric refrigerator. Okay, I will name it as ER. Next, here I will take an electric iron box. I will call it as IB. Okay. Next, here they have given its power rating is how much? 400 watt, and it is used for a time of 8 hours per day. And here the power rating is 750 watt, and it is used for the time 2 hours a day. Correct? Now we need to find cost of using these appliances for 30 days. So how much power they will consume for 30 days, correct? So electrical, here the power consumed you can write, or electrical energy consumed, power consumed for 1 day. First you calculate, which is P into T, right? So 40 watt into 8, how much is this? 3200 watt hour, right? This is watt and this is hour. Now we need for 30 days. For 30 days, same, this power consumption is 3200 into 30. If you do, this is 000, 3 2s are 6, 3 3s are 9, 96 watt hour. But they have given in kilowatt hour, so you should know 1 kilo is almost 1000, right? Watt hour, so 1 kilowatt is 1000 watt hour, that's all. So what you can do, instead of this you can write 96 kilowatt hour. Okay, so this much energy is used by this refrigerator in 30 days. Now coming to iron box, here again the power consumption or electrical energy is equal to 750 into 2. Okay, because this is 750. Next 0 0 7 to the 14 15 watt hour. This is per day, in a single day. Now for 30 days it will be 1500 into how much? 30. So how much is this? 45 1 2 3 watt hours, but we need in kilowatt, so just divide by 1000, means just remove this 3 zeros, this becomes 45 kilowatt hour. Now these two combinedly, okay, 96 plus 45 combinedly, they will consume this much energy in 30 days. So when we add them, we'll get 13 1 14 141 kilowatt hour, right? 6 5 11 9 4 13 1 14. Therefore now you can write cost of using this for 30 days is, for 1 day uh, it was for 1 unit it was 3 rupees. Okay, for 1 kilowatt. For 30, for 141 it will be 141 into 3, which is 3 3 4s are 12, 3 1s are 3 plus 2, 423 rupees only. Understood? I hope it's clear. It's very easy, just you have to understand and solve it. Your math should be good, only then you can solve this. Okay, moving to the next question. Next we'll move to the next set of questions. Okay, these are exam questions and they're very easier. Just look at them. Here they have given the resistivity of manganese wire of length 1 meter is this much. Okay, at 20 degrees Celsius. Okay, if the diameter of wire is this, what will be the resistance of the wire? Okay, so first always try to write the data. They have given resistivity, means rho they have given, that is 1.84 into 10 to the power of minus 6 ohm meter. Of length also they have given, let me write L1 meter. Okay, at 20 degrees Celsius, this is normal temperature, no need to write that. The diameter, okay, so if the wire is like this, if you look at from here, this will look circular, therefore the diameter of this circular wire they have given, it is 3 into 10 to the power of minus 4 meter. What will be the resistance? So just by looking at the data you can imagine which formula you are going to use. You have rho, you have R, correct? So rho is equal to RA by L. I hope you know this. We need to find R. So R will be what? If you do cross multiplication, it's become rho into L by A. We have rho, we have L, but do we have A? A is what? Area of this cross section of wire. But we have given diameter. We know that area of circle is pi r square. Now what is R? It is d by 2, correct? So d by 2 whole square. So this becomes d square by 4, isn't it? So just substitute this. Pi is 22 by 7 into 4 into diameter is, write it twice, so 3 into 10 to the power of minus 4 whole square if I write. Now this becomes 22 into 3 3s are 9, and this becomes 10 power 4 minus 8 divided by, what is this, 7 into 4. Now can we solve this? Yes, we can cancel this. 11 2s are 2 2s are. So this becomes 1199. 11 9s are 99 into 10 power minus 8 divided by 7 2s are 14. What is this area? You can keep that this much. Okay, don't try to write in decimal. Just write this much itself. Okay, now this a you can substitute here. So resistance becomes, what is rho? 1.84 into 10 power minus 6 into L is 1 divided by area 99 into 10 power minus 8. This 14 will go to numerator like this. Now this becomes 1.84 into 14 into 10 power minus 6. If I bring this to numerator, it becomes 10 power plus 8. Correct? I hope you know that exponents form divided by 99. So now if you see, 8 minus 6 is what? 2. 1.84 into 14 into 10 power 2 divided by 99. 10 power 2 means how much? 100. Correct? So if you do multiply, this becomes 184 into 100, right? If you do this with 100, and this is 14 divided by 99. Got it? Now you can solve this. Okay, how can you solve this? You can just divide them. So after solving this, what you can do, you can just multiply these two, then you can divide by 99. Okay, I hope you are good at calculation, that is multiplication. So after solving this, you may get 26.02, and this is resistance, therefore the unit is ohm. Okay, and try to box it like this. So this is the answer of the question. Okay, I hope you have understood this. Next, moving to the OR question. These are exam questions, so try to practice them. Okay, only if you practice you will become better. Okay, practice makes you better, not perfect, because nothing is perfect na. Okay, observe the given circuit. Okay, I can observe it, I hope you too can. Now calculate the total resistance in the circuit and total current flowing. They have asked total resistance, so we have two set of resistance. One is in parallel, correct, and that parallel is parallel to this, isn't it? So a set of two parallel connections. Sorry, if you draw this, you'll get this single parallel becomes like this, and that is connected to this in series only, because this is just bended. If I elongate it, it's become like this, right? If it was parallel, it could have been like this. Okay, but it's not following here. They are in parallel, these are in parallel, but the one which is a single will be series. It should be in series with this. Got it? So how are you going to solve it? See, first we will calculate the resistance in parallel, the total resistance in parallel, okay, of this. So what is that? It is 1 by Rp is equal to 1 by 2 plus 1 by 4 plus 1 by 4. Okay, so 1 by Rp becomes, if you take LCM, you will get 244, 212, 2111, 2 2s are 4. So 2 2s are plus 1, which is 4 by 4. So 1 by Rp is equal to 1, therefore Rp is also equals to 1 ohm. So this total is 1 ohm. Now this is connected with this in series, correct? So therefore total resistance is equal to 1 plus 5, which is equal to 6 ohm. This is the total resistance in this circuit. Now they have also asked to find total current. So again use Ohm's law. V is equal to IR. So I will be V by R. V is given as 6 and R is also 6. So 6 by 6 is 1 ampere. That's all. It's very simple. Next is this question. Observe the figure given in the diagram. Okay. Calculate total resistance in total current. So total resistance, first they are in parallel. So first we have to find them. So parallel, 1 by 4 plus 1 by 12. So 12 LCM, 3 plus 1. This is 1 by Rp. So 1 by parallel is 4 by 12, which is 1 by 3. So 1 by Rp. When you reverse this, becomes 1 by Rp, becomes Rp, and that is equal to 3 ohm. Now 3 ohm plus 5. So 5 plus 3 is how much? 8 ohm. So total, this is total resistance, which is 8 ohm. They have also asked total current. So again, V is equal to IR, I is equal to V by R. V is given as how much? 24. So 24 divided by, what is this? Resistance, that is R, 8. Okay, so 8 threes. So again, here current is 3 ampere. I hope you have understood all the type of questions which I have explained till now. If yes, do press the like button. Okay, moving to the next set of questions, and they are very important. They are mainly from the textbooks. If you know, you can skip. If you don't know, just solve it and learn. The first question, they are very simpler one. I will try to solve them as fast as possible. Okay, I hope you are watching my videos at 1.5x speed. No, 2. Okay, because I have seen it look normal when I watch it at 2x speed. Try it, or else 1.5. Next, a bulb is marked 220 volt and 40 watt. Okay, so they have given V 220 volt and power. Just by looking at the unit, you can get what have they given, 40 watt. Calculate the current flowing through the bulb and its resistance I as well as R. So as I said, VIP, VI is equal to P. See, they have given VP. They have asked I. So I will be P by V. What is P? 40 by 220. So 0, 0 will become 2 2s are 211. So write it as 2 by 11 ampere. Try to keep it in that format. Now resistance. Use this formula, Ohm's law. So V by I, what is V? V 220 divided by I is 2 by 11. So 11 you write like that. 2 ones are 2 11s are. 11 11s are 121, and this is 0. See how simpler is that? 1210 ohm. Got it? Moving to the next question, and it is given as, you can read it. Sorry. See, a current of this ampere is drawn by a filament of electric bulb for 10 minutes. Okay, find the amount of electric charge that flows through the circuit. Okay, so current is given, I is given 0.5 ampere, and they have given time in minutes. So whenever they give in minutes, try to convert it in seconds by multiplying with 60. 1 minute is 60 seconds. I hope you know that. So 60 tens are 600 seconds. We need to find the number of charges, Q. So as I told you in the beginning, current is Q by T. What is Q? I into T, right? I is 0.5 into T is 600. 0.5 is half. So half of 600 is how much? 300 Coulomb. Understood? That is the answer. Next, how much work is done in moving charge of 2 Coulomb across 2 points having a potential difference 12 volt? So they have given Q, which is 2 Coulomb. They have given voltage, that is potential difference is also known as voltage, 12 volt. Now they have asked how much work is done. So in the beginning I have given W, V is equal to W by Q, right? W will be V into Q. What is V? 12 into 2, that is 24 joules. This is very important. Units are very, very important. Okay. Next question. An electric bulb is connected to this generator. Okay, voltage again is given as 220 volt. Current is 0.5. Okay, I is 0.5. What is the power? So again, P is equal to VI. Simple. So 220 into 0.5. 0.5 is half of any value. So this is 110 watt. See, all of them are 1 mark questions. Okay, I hope you can do them now. Moving to the next question, which is important for 2 marks. Next, how much current will an electric bulb draw from 220 volt source? Okay, if the resistance of bulb filament is this. Next, B, how much current will an electric heater coil draw from 220 volt if the resistance of heater is this much? Okay, so these are 2 set of questions. So in a question they have given voltage is given as 220 volts and resistance is given as 1200 ohm. They have asked current, so it's very simple. V is IR, I is V by R. 220 by 1200, 0 gets cancelled, 2 11s are 2 60s are. So it is 11 by 60. You can solve this or you can keep it as it is. Okay, you will get answer in some 0 point some value. Okay, or keep it as it is. Next, in B they have given, again they have asked current, voltage is given 220 volt and resistance this time is 100. So again I is V by R, use the Ohm's law, simplest form. So this time it's become 2.2, correct? V is 220 by R is 100, so 2.2 ampere. Got it? Next question, question number this one. They have given, let me erase them first. I hope you are enjoying it and not getting bored. Kindly do press the like button if you have not done it yet. Okay, you can only support me by doing that, no other way. Like, comment, share karo bachcha, share karo. Okay, the potential difference between the terminals of an electric heater. Okay, again just write the data. Potential difference is V, it is 60 volt. Current draws is 4 ampere. What is the current? Okay, what current will the heater draw if the potential difference increased to 120? Okay, so this is a little different. So what will be I when the voltage is 120? So first find R. Why? V is equal to IR. So R is V by I. 60 by 4, 15. Correct? R is 15 ohm. Now using this, V is equal to IR. So R is given, V is given, you need to find I. V by R. So V is how much? 120 by R is how much? 50. Both of them are divisible by 3. 3 5s are, and this is 3 4 T. Next 5 ones are 5 8s. So I is 8 ampere. That's all. Very easy, right? Yeah. I hope you are getting it. It's very simpler. You just have to remember those fixed formulae, substitute, and get easily 3 to 4 marks. Okay. Next question. A wire of given material having length L, okay, and a cross-sectional area A has resistance 4 ohm. Okay, what would be the resistance of another wire of same material if the length is L by 2, acha, and area of cross section is 2A? If it is of same material, okay, conductor is of same material, then the resistivity remains the same. We can write this formula, rho is equal to RA by L. Again here rho is equal to RA by L. Here R is 4, A is A, L is L. Here R is Gotilla, pata nahi humko. A they have given as 2A, L they have given as L by 2. So L by 2, if I write 2 will comes to numerator. This becomes 4AR by L. And here this is 4A by L. Since both of them are rho, rho se rho mila do. So this becomes 4A by L is equal to 4AR by L. L चले गए, 4 चले गए, A चले गए, बच गया R, and here it is 1. So R is equal to 1 ohm. That's all. Understood? It's very simpler. Moving to next question. So the next question says, in the figure 12.12, okay, this is the figure. R1 given, okay, it is 10 ohm. R2 it is 40 ohm. R3 30, R4 20, and R5, okay, this is R5 60. Okay, and a 12 volt, okay, this is volt, 12 volt battery is connected to the arrangement. Calculate the total resistance, okay, and total current. So total resistance will be this resistance plus this total, correct? So these two are in parallel. So just do that. 1 by R, let me call them 1, okay, RP. So 1 by 10 plus 1 by 40, correct? So this is 40, this is how much? 10 fours are 40, 10 ones are, so this is 5 by 40. So 1 by Rp is equal to 5 by 40, which is 1 by 8. So therefore Rp, when you solve, it's become 8 by 1, which is 8. So this is 8 ohm. Now if you solve these three, so 1 by Rp, again 1 by 30 plus 1 by 20 plus 1 by 60. So 30, 20, 60 LCM is how much? 2, 3, 6. 2 ones are 2 threes are, correct? 2 ones are 2 threes are 3. 1, 1, 1. 3 2s are 60. 60 will be LCM. So here this will be 2, here it will be 3, here it will be 1. So 3 plus 2, 6 by 60, which is 1 by 10. So again here Rp is reciprocal of this, which is 10. So now this total is 10 and this total is 8, and they are in connected in what? Series. So just add them. 8 plus 10 is how much? 18. So total resistance we got is 18 ohm, and total current is again V is equal to IR. So I is V by R. V is given as 12 by 18. 3 4s are 3 6s are 2 2s are 2 3s are. So 2 by 3 ampere. This much you can write, or also you can write in decimal form. 0 point, you will get 3 6 18, again 3, 0.66 ampere you may get. Got it? I hope it's clear. Moving to the next question. They're very easier and simpler. I hope you are getting that confidence now. If yes, फटाक से वे like button दबा दो बच्चा. Okay. Next question. They have given a battery of 9 volt is connected to series with this and this respectively. How much current would flow through 12 ohm resistor? Okay, so first they are in series, so let me add them first. Total resistor will be 0 0.2, 0 0.3, 0 0.4, 0 0.5. When we add, this become, and this is 12, 12.0. So 5, 5, 10, 10, 10, 14, 1 carry, 2, 1, 3, 1. 13.4 is the total resistance. Now current they have asked. So current remains same, okay, with all this, because they are in series, and as I said, PV Sindhu, remember that. So in series connection, current is same. So whatever current is going through this, it will be same through this, and also 12. So find that current. V is IR, again I is V by R. So V is how much? 9 divided by R is 13.4. Okay, so this much you can write. I is this many ampere, this much ampere, or else you can also solve this. So solving is very easy. Just divide 9 by 13.4. You will get how much? You will get around 0.67 ampere. Okay, if you don't want to do this, even if you write this much, you will get the answer. Okay, moving to the next question now. Question number, I don't know, I hope you know that if you're writing in line. This is the question. Two lamps, one rated this and this at, and the other is this are connected in parallel. Okay bacha, so एक lamp here, another lamp here, they are connected in parallel. Okay, what current is drawn from the line if the supply of voltage is 220? Okay, so here this is 220. Here they have given power 100 watt. This is little different, and voltage is 220. Okay, okay, the same voltage is going here. Again here they have given power 60 and voltage is same. So voltage is given, this is given. You need to find what? I we need to find. So how are you going to do? So you know that in parallel connection, what is same? PV, voltage is same, but I is different. So you have to just find I separately and then add them. That's all. Correct? So what I will do, P is equal to, I know that VI. So for current in this, I'll name it as 1 and here 2. So I1 will be P by V. P is 100 by V is 220, which is equal to 5 by 11. That's all. Correct? Next, P is equal to VI2 from here. So I2 is P 60 by 220. Sorry, so you will get 3 by 11. So now just add them. The total current will be I1 plus I2. So 5 by 11 plus 3 by 11. 11 is common, so 5 3 8 by 11. Okay, this much if you write you'll get, or when you divide this you'll get 0 0.71372. Yes, 0 0.72 ampere. That's all. Isn't it easy? Yeah, it's very easy. Who is teaching you? My name is, I hope you know my name. If you know, kindly write it in the comment section. Let me know. I have forgotten my name. Oh my god, what was my name? Falcon Learning Point? No. If you know my name, do write it in the comment box and let me know my name. भूल गया हूँ भाई, याद दिला दे जरा. दिलाओगे ना? दिला देना. Okay. Next question. When a 12 volt amp battery is connected across unknown resistor, there is a current of 2.5 milliampere in the circuit. Okay. Find the value of resistance in the resistor. Okay. Again, it's very simple. V is 12 volt and current is 2.5 milli. Milli refers 10 power minus 3 ampere. You have to write always in ampere. Next, find the resistance. So V is IR. I is 2.5 into 10 power minus 3 into R is 12. So how much are you going to get? So this is 25 or 2.5 into 12 by, if you bring this denominator, this becomes 10 power 3. Okay, so when you solve this, okay, how much are you going to get? This is okay, if I multiply here 10, again 10. Why? Because this becomes 25, this is 12, this becomes 10 power 4, right? So now how much will you get? So 25 into 12, if you know that, 250 into 50, right? 25 plus 50, 2, it is around 300, I guess. Yeah, 300 divided by 10 power 4, it is around 0.3. Okay, this is the answer, 0.3 ohm. Okay, I hope it's clear. If I have done any mistake, let me know. Yeah, I have done it here. V is IR. We need to find R, but I'm finding V. So this is mistake. R is what? V by I, correct? What is V? It is 2.5 into 10 power minus 3 into what is I? I is किधर है भाई? V by I. 12 by this much you have to do, correct? So this becomes 12 into 10 power 3 divided by 2.5. So this is 12 into 10 power 4 and this becomes 25, isn't it? So 25,000 divided by, if you do 25, you'll get 400, right? Into 12, if you do, how much will you get? You'll get 4800 ohm. This is the answer. Got it? I hope you have understood. Moving to the next set of question. Okay, so this will be the second last question. In the last question, if you have solved from the starting, I think you can do it by yourself. Try to solve this and write the answer in the comment section. And also don't forget to write my name if you know. If you don't know, ask me. I will tell. I will go refer my certificate and I'll get the name and will tell you in the comment section. Okay, but if you know, you can write it. Yeah, so solving this problem now. An electric iron consumes energy at a rate of 840 watt when heating is at maximum rate. Okay, so maximum rate it's consuming 840 watt. Okay, next 340 when heating at minimum. Okay, when it is by heated at minimum it's consuming 360 watt only. Okay, when the voltage is 220 volt, again it is 220 volt. What is the current and resistance in each case? So here current first and resistance, again current, resistance. So VI given, so use that VIP formula. P is equal to VI. We need to find I is P by V. What is P? It is 840 divided by 220. So how much will you get? 84 by 22. When you do, after solving, you will get around 3.81. So try to solve it. This is ampere. Now resistance, you can use V is equal to IR. Okay. So we got it as how much? R we need to find. V by I. V is 220. I you can write this directly. So 840 into 220. 0 to cancel. Next on solving this, I am solving this directly. Okay, you try to do it line by line by cancelling. Okay, you may get this as 57.61 ohm. Okay, and here again you can do it same using I is P by V. So P is 360 by V is 220. 0 cancel, you'll get 36 by 22, correct? So after solving this you'll get 1.63 ampere. And resistance again V by I, correct? So V is 220 by I 1.63, and after solving this 220 divided by 1.63 you will get 134, approximately 0.9 you can write ohm. Okay, so this much are the questions. I have explained it to you. In this last question, where is it? Kidhar gaya re baba? Yeah, try to write this in the comment section. Okay, and don't forget to write my name too. Thank you for watching. And one more important thing, these questions which I have written here for 2 marks. Array, what happened? Yeah, try to learn them. Okay, they are very important. Whatever in this diagram, resistors in series and parallel. And in 3 marks they mainly ask, yes, this states Joule's law of heating, state Ohm's law. Okay, all these questions try to, in this third question, they're very important. Learn them. If you don't have the answers, you can text me on WhatsApp or write it in comment section along with your phone number. I will try to, that will be very difficult. You can just come to Telegram, link is there in the description box. Text me there. Okay, join the group, text me, I will try to answer it. Okay, or I will try to send it to your number once you are in the group of my WhatsApp. Okay, so with this let me thank you and wish you all the best for your exam. Do well. Okay, माँ बाप का नाम रोशन करो, हमारा तो भाई हो ही रहा है. Okay, so see you all. Thank you again.